I've never seen it that bright before. Well, let's see if this belt's going to stay on. What do you think? I don't know. Okay, y'all, so after our little test that didn't work out too well because it was flexing, I think my only alternative is going to be to disassemble my whole drive, cut this completely off and this completely off, and turn it round in the lathe again and actually fit it into a piece of box tubing, so that way it cannot flex and it'll be perfectly straight. And because this obviously just flexed way too much, because I'd milled the top of this out so that could fit under there, so that of course weakened it, and then that just let that flex way more than I would have ever anticipated. Also, I need to redesign it to where I have a way to tighten the bearings more than just what I had, because I'd tightened the belt good, but when I started disassembling it, I noticed that it had so much torque that it actually had lifted my whole plate up in the slots. So my slotted plate there, that was a fail. So anyway, yeah, nothing else. I got a nice big plate of aluminum to do something else with. But yeah, so that was a fail. So what I've got is I have over here a piece of aircraft aluminum box tubing, and this was an axle from a gyrocopter, and that is 1/4 inch thick box tubing. And like I say, what I'm gonna do, I'm gonna just bore a hole completely through there so that when I turn that shaft down round, it can fit in the hole. That'll keep it perfectly lined up. Then I'll slot it down the bottom, put my bearings on, and go from there. So anyway, I've got it partially disassembled. I'm not totally dead in the water. Pretty disgusted that that didn't work out, but in a way that was pretty heavy anyway, so if I can reduce weight by replacing all that steel with an aluminum box tube, then so be it. And I'm thinking, if that box tube bends, considering it was designed to be an axle for a 600-pound gyrocopter, then there is a serious problem. I'll have too much horsepower if it can bend that 1/4 inch thick box tubing. That looks like that's going to be my best plan. Like I say, I'm going to have to disassemble my whole thing, take the bearings off and everything, so I can then mill that completely off and be able to put it in the lathe and turn it totally smooth. But think that's my plan. I think that's what I'm going to end up doing, and we'll just kind of see how that works out. Anyway, that's what I've done. it's late. I'm tired. Pretty disgusted, but at least I got that disassembled. Like I say, there was my drive plate that unfortunately didn't work as well as I would have liked to. Obviously I did not anticipate that thing would have that much flexing and would actually have enough to actually pull that whole plate upward. So my belt was actually loose when I took it loose, and as you saw in the other video, this was flexing like hell. So anyway, till tomorrow, we'll see what the hell happens. Hello boys and girls. In today's episode of Am I Gonna Die in My Machine Shop Today, we're going to turn down this big 3.5 inch diameter piece of steel. Attempt to, if it doesn't kill me slinging out of the lathe, down to 1 inch diameter all the way up to about here, which then will then turn into a flange and have also like a nipple area, whatever you want to call it, sticking out about 1 inch. That will then go into our drive pulley here. Let's see if I can pull this off here and let you see the drive pulley. Well, of course not. Okay, so basically there's the drive pulley, and you can see it's bigger than the 1 inch diameter shaft we had it on before. So, and with this the way it was, there was no way I could put my bearing on the outside of the frame like I needed to and be able to get the pulley to line up, because I had to use this flange here to hold my pulley. So what I'm going to do is I'm going to turn this whole piece of metal down to where it will be one solid piece, where about that much of it will go up inside the drive pulley, up into there, and then we'll have a flange. Leave it to full diameter. That'll come out probably about maybe not even a 1/2 inch, 1/4 inch, something like that. And then the rest of this will be turned down to 1 inch. So that's going to be a lot of wasted metal. It's going to take a long time. But when I'm done, I'll have a complete one-piece drive shaft for the hovercraft, where everything will be perfectly centered. Won't be any, I know it won't be any kind of bent tubing, because everything's bent shaft, because it's going to be all turned on the same lathe. So like I say, it'll have like a nipple go up into the pulley, which will support the weight of the pulley and stuff. Then it'll have a flange to just have the 4 bolts be drilled into holding the pulley on, and then one whole solid shaft all the way back. So that's the plan. Now, as long as I don't die trying to do this, what I'm going to have to do is I'm going to have to put my center drill in first, and center drill the hole in the end, so then I can run my live center. Once I get it where I have my live center in there, then we should be good. But that piece of bar probably weighs 50 pounds. It was ungodly. I just broke the bank. I had a little bit of money saved. I've been trying not to spend it, but I think this is going to be my best thing if everything works out like I want it to. I don't even want to say how much that piece of steel cost, but that will cure my problem. If that don't cure the problem, nothing will, because like I say, I'm going to slot the piece of box tubing. You can see the box tubing I got. You can see I got my flange already in there, and I'll be sandwiching the box tubing just like that, and then have my other coupler piece on there. But it'll be all one solid piece that's then going to be able to line my pulley up perfectly. And because you can see right there, if I have that all machined in one piece there, then that will allow me to have the perfect distance and have that pulley perfectly lined up. So we were able to buy this piece of box tubing yesterday. Like I say, between this piece of box tubing And I got me a brand new piece of box tubing for a cross piece there. I broke the bank. I'm now officially broke. I was trying not to spend what little money I had, but oh well, gotta do what you gotta do. And yeah, so anyway, I think it's gonna work out good. It's definitely gonna look better than the other stuff did. And like I say, you can see what I did is I bored a hole all the way through and put the shaft all the way through there. It's held in with a locking collar. What I'll do is I'll put a bolt through there to keep it from spinning, and that should have me perfectly lined up on the drive setup now. So like I say, now to turn that down, if I don't die, it'll be a miracle. This will probably be an all-day process, and who knows, it might take more than a whole day. But it's going to be a lot of wasted money, metal, a lot of wasted metal. But that's why machining costs so much. Materials ain't cheap. But like I say, when I get done, I should have me a nice precision shaft with a flange on it, and that should cure my problem. So stay tuned. This is Merlin. I'm out. So far, I've got it turned down about 1/16 of an inch because my tooling's crap, and now my half nut's wearing out and the power feed's not wanting to work right. I'm telling you, I just can't win sometimes. Anyway, yeah, this is not doing like I wanted it to. So anyway, who knows? I'm calling it a day. This thing just ain't doing. We'll keep you posted. Okay, y'all, Merlin here again. So, since this has failed out and I'm going to have to take the lathe apart, you can see just how little metal I actually got cut off of there. And you can see the surface looks like crap. So anyway, until I get some more lathe tooling, I did find some on Amazon that was pretty cheap, so I've got some orders. They'll be here Tuesday. Sadly, I still got to hand crank it because what they call the half nut, which is that piece right in there, you'll see when I raise the lever how it engages that right there. Well, unfortunately, my half nut has stripped out, so it's no longer powering the table for the power feed. So that sucks because I don't even know where I'm going to order a half nut from. I hear you can get them from Grizzly Tools, but they're about $59, which I don't have, so I'm not going to really worry about that at the moment. What I have done is I have gotten some more metal the other day, and I have made a actual fan, drive fan hub. You can see that it's actually working. It's got good clearance. It's close into the frame. I haven't put any bolts through there yet to hold that, but I've got it clamped in place, and I have taken and cut a place for my shaft and notched it so that it would be able to be adjusted up and down. What I want to do is take and mill me out an opening here where I could put a eye bolt in through the bolt that would go through here, because I'm going to have two bearings sandwiched on there, one on each side. And what I want to do is be able to put the eye bolt in so that it could raise up and down. You can see it will adjust here up and down to adjust the belt tension. And what I want to do is put an eye bolt that would go, this bolt here would be able to go through the eye bolt, and then have like a plate in there so you could adjust the eye bolt and put tension on the belt to tighten the belt. So anyway, that's where we're at. Yeah, that's what our plan is. What I have noticed, of course, my hovercraft's different than every other hovercraft around, and I'd had to make this metal plate to mount my other stuff. Well, as you can see there, that bolt's not going to let it adjust right there. So what I'm going to have to do is take that plate out and mill just a tiny little slot where my bolt would be able to go, because as you can see, the edge of the bearing would just barely be able to fit in between there, and that would limit me from being able to raise the bearing up and down to adjust the tension, because like you say, it's hitting, so you wouldn't even be able to put a bolt on there with a nut to be able to go up and down. So I get to reach in here now, and lucky I can get my hands in there to the plates, and I'd be able to take those 4 bolts out. So maybe tomorrow I'll try to take that plate out, mark it beforehand, and put it in the mill and mill the little slots so the bolts could be adjusted up and down, and get this together. But yeah, we got a good strong cross piece now. It's made out of 1-inch steel box tubing. The main frame here is 1.5 inch by 3-inch steel box tubing. It's good and strong. I don't think it's going to go anywhere. And so now we got a more professional looking drive frame. Like I say, still got to make some braces and things for it, but that's looking pretty good. If I can learn how to use my welder, what I'd probably do is just spot weld my stub shaft in place once I've got everything lined up right, and put a weld across the cross pieces, and have me a pretty good looking drive frame. So anyway, that's what the plan is. Like I say, one of the guys on the forum sent me pictures of how his drive was set up, where it had these same type bearings sandwiching the tubing. So that's kind of pretty much what I'm trying to duplicate, and that will be proven and should work. But like I say, everything's built differently, and well, mine's definitely built differently. So to make everything work, because of the distance of my bearings, that's why I'm having to turn this shaft down to do like I'm going to do to make a solid one-piece shaft that the drive pulley would then be able to bolt onto. So anyway, that's where we're at with things. I'll keep you updated. This is Merlin. I'm out. Well, I'm almost down to the correct size for fitting it for the bearing. You can see I'm really close here. I'm not going to cut it down to the final size yet, because I'm going to go ahead and let the metal cool down and chuck it up so I can cut this area out to fit the pulley. But yep, we're getting close, getting real close. So that's where we're at. Like I say, been a lot of work, but we're getting to the home stretch here. I think it's going to be worth all the effort, because at least I'll know I'll have a perfectly straight shaft and a good solid hub mounting my pulley to. And since I'm going to turn it down where it's like a stud sticking out this side for the pulley to bolt down onto, that'll have my pulley fully lined up also. So everything should run totally straight when done there. So that's where we're at. I think it's gonna work out okay. Like I say, it's been a lot of work. A lot of wasted material, but in the end it'll be worth it. So we'll see. This is Merlin. I'm out. Alright, well, other than doing some finish cutting tomorrow, I've got my thing finished up. What my plan is to get this to where that's going to fit right over there and bolt nice and flat on there, just like that. And what I got to do tomorrow is finish cutting it to size. I want to let the steel cool down, and then I'll put a brand new cutting tool in to finish it up. But that's what my plan was right there. That's what the whole plan was right there. So yeah, whole lot of metal, but there we go. There's the lower belt drive hub. So I think that's going to work out pretty nice. So anyway, yeah, I think that's going to do me. I'm happy with that. That looks pretty good. Anyway, I'm going to clean up and call it a night. This is the Merlin. I'm out. Okay, well, as you can see, my drive frame is getting closer. I've got stuff lined up enough where, now my belt's not tight of course, but I can actually rotate my shaft, so that tells you that everything's lined up like it should be. So what I got to do next is I got to disassemble it. I put a mark on the front of the pulley and one behind, and the drive adapter. So what I'll do now is tomorrow I'll pull that back out and put it in the milling machine and mill me a keyway slot, a key slot for the adapter thing. And then what I'll do is I'll cut the access shaft off with just enough room to put a locking collar on the back side and one on the front side, and that will then keep the shaft from traveling, besides also locking down the set screws on the shaft. But that's what I did. There's the piece. That's what I'd been machining for almost a month now. Crazy. But yeah, that's it. That's the custom shaft I made, and you can see that was what all the work was been for. It's been a long road, but it's on there. I haven't put my nuts on the end there. I just got some temporary nuts tightened down there right now. And then I got to do something better on here because the weight's pulling down on that and pulling it off being center. So what I'll probably do is put like a piece of angle or something under there for that to lay against to reinforce that. But that's what we got. That's the new drive frame coming together. And yeah, right now as I'm rotating it around, the belt's trying to travel off the end. So of course that's because this is like pulling downwards. I'm sure that's the reason. But that's what we got. Been a lot of work, but I think it's going to work out nicely because, like I say, the engine's actually sitting in there now where I can actually rotate that shaft. So if there was any binding, if it wasn't straight, I wouldn't be able to rotate that shaft inside that hub. So I think that's going to work. So that's where we're at with that. Being eaten up by mosquitoes now. So anyway, this is Merlin, and I'm out.